let's get ready with the Zero to Hero series on the topic of, yes, waves, and that is string and waves on a string as well as waves of sound. Welcome aboard. Hello Anish, Monkey, Jagdish, Snehal. Welcome Nancy. Hello everyone. And remember guys, if you are here, do not forget to leave a comment, leave a chat on the chat box, because that's the only way you can mark your attendance and that's the only way you can make new friends out here. So welcome Ankit, good morning. Yes, welcome aboard. Yes, there is a V.O.T.E exam on 18th April and that's the last V.O.T.E examination and that's your last chance to get your Vedantu scholarship. So in case you are not registered, do not forget to register by hitting on the link below in the description box. Hi Anushri and happy Vishu. Yes, same to you. And yesterday there was Gudi Padwa and today there is Vishu. I am guessing Vishu is celebrated in Kerala, and I am guessing you are also from Kerala. Hello Jagdish, good morning. Yes, good morning everyone. Hi Liger, were you sleeping? No Liger, I was not sleeping. There was some issue with the chat and I was not able to figure it out. So, you know, I just took some time, 5 minutes in the start, just to get the chat properly working. Okay, so, you know, from the admin side. All right, hi Rookie, Foxtrot, hi Jacob, hi Shruti. Hello, welcome. Yes, Kiruto is present. So let's begin with our session and get ready guys. We're starting with the waves on a string and sound waves chapter. And in case you have not yet liked our video, so guys, I keep asking you guys, do not forget to hit the like button and do not forget to hit the subscribe button in case you are new to this channel early in the morning. So welcome aboard. Welcome. Hi Satyendra, welcome aboard. So guys, these morning classes are meant to freshen you up. It's meant to get you in a habit of, you know, making sure that you lead a healthy life by making this morning wake up as a routine and making sure that you guys stay healthy, not just physically but also mentally. And plus the day feels longer. Correct me if I'm wrong. When you wake up in the morning, it's only till you get up from your bed. How many of you feel that? It's only till you actually step your foot out, brush your teeth and probably just wash your face or something, and after that it feels all normal, because then you feel like, oh yeah, good, I woke up, you know, now I have so many things to do, I have so much of time. Suddenly the day feels longer. Isn't that so? Welcome aboard. Hi Fatima, welcome aboard. Yes, oh my god, Monkey is going to sleep after the session. No Monkey, don't do that. Sleep in the afternoon, not now. Okay, so V.O.T.E exam last date, yes, that's 18th April. So do not forget that, and the link is there in the description box below. And guys, if you're one of those who feel that you know, you are quite late for the April attempt, or who feel that probably you cannot make it for the April attempt JEE Mains examination, or if you feel that your preparation is not up to the mark and doing it on your own might probably take you a lot of time, guys, we are always there to help you. Remember, we are conducting the Zero to Hero series for 2021 aspirants as well as 2022 aspirants. So any topic that is left out, this is a quick revision series, Zero to Hero, for all the 2021 aspirants. And if you want more help and if you want somebody to help you out with all the chapters of 11th and 12th in the live classes, plus you want test series, plus you want the discussions, plus you want some questions in a very quick manner, in a very crisp, clear manner, then remember, we always have an option for all of you, and that is the crash course, where you get the 11th and 12th standard portions in 45 classes along with the replays. Plus you have teachers like me who I know personally who are teaching the physics, chemistry, maths batch, and you also get an option to solve all your doubts right from morning till the night through the doubt app inside Vedantu, only when you join the crash course. And there are 20 test series, 15 of them are full syllabus, 5 of them are part test syllabus, and it also carries with it the discussion, which is very important after every test. So do not forget to check out the crash course, which is there on every evening. And in case you have missed the crash course, which started on 5th of April. So guys, there is 4th of May crash course also available for all of you. You can even join the previous crash course and watch the replays. It's up to you. The course price was actually 10,000, but you get an offer of 4,000 rupees off, and that's when you use the coupon code SHCC. So do check it out. The link is there in the description box below. So let's get going. Now look at this slide. This is very important slide. We are starting off with, the theory part. Slowly we are going to go to the problems part as well. So start looking at the theory, very important. You are going to get notes as well. You're going to get notes as well. So first of all, remember wave speed is frequency into wavelength. That's the standard relationship. Then you have time period of oscillation, which is very similar to that in circular motion or in simple harmonic motion, which is 2 pi by omega. That's over here. Then you also have angular wave number, which is 2 pi by lambda, which is related to the wavelength. So K is angular wave number, that's radians per meter. So remember, if more the wavelength, angular wave number is less. This is radians per meter. This is angular frequency. This relationship is very similar to that you find in SHM or even in circular motion. Wave speed is frequency into wavelength. Standard relationships which you should know. Now, whenever you see a wave equation, hello Karthi, hi Yalini, welcome aboard. Whenever you see a wave equation, remember that if you have minus in the equation, then the wave is actually traveling in the plus direction. And if you see a plus in the equation, then understand the wave is actually traveling in the minus direction. There are many questions on this in today's session, so be careful about it. So in fact, whenever you have some function and there is ax plus minus bt over here, remember that if it is plus, it's actually traveling in the minus x direction, and if it is minus, it's traveling in the plus x direction. And the wave speed is given by b by a. Keep this in mind, okay? And whenever you have a sine wave, this function will become sine. Look at this function will become sine, all right? That signifies the shape. So basically this function tells you the shape of that wave. If it is something else, it will accordingly change the shape. So if a wave is like a sine wave, then the function should be sine, and you can see that. Okay, so that's how this works. I hope you have noted down all these formulas, guys. Let's get going to the next one. I'm giving you all the important formulas from the waves chapter, waves on a string and sound waves. Next up, for sound waves, which are longitudinal waves, these are nothing but longitudinal waves. Keep this in mind. So if it is longitudinal waves, that means the particles move parallel to the wave propagation. So if the wave moves like this, the particles will move parallel to the wave propagation like this, and the displacement of any particle of the medium is given by S0, and again sine or cosine doesn't matter, again kx plus minus omega t. This can be also written down as S0 sine of kx plus minus omega t. Instead of sine, you can also use cos. It really doesn't matter. Keep this in mind. But keep this in mind that if displacement is sine, then pressure of the wave will be opposite. If it is sine, this is cos. If that is cos, this is sine. Why? Because remember, between displacement and pressure, the phase difference is 90 degrees. This is very important thing. I have talked about this in the flash series, but you should know this. The phase between displacement and pressure is pi by 2 radians. Keep this in mind. So if this is sine, this is cos. Last thing, hello Nitya, hello, welcome. Last thing, speed of sound waves. Inside liquid, it is root of bulk modulus by rho, inside liquid. But in solid, instead of bulk modulus, you put Young's modulus. And in gas, it is gamma p by rho. Basically, this is ideal gas, so gamma p by rho, which you can also write it as gamma RT by M. Everybody remembers this? Everybody up? Everybody understood? Everybody remembers this formula? Let me know if you guys have noted it down, if you have taken a screenshot, and if you guys are ready to move on to the next slide. Yes, pressure wave important for JEE. Yes, there have been questions, Snehal, a few number of times where the question was on pressure, but it's rare. This one is rare, but if it comes, it will come. I mean, that's it. It's a rare thing. Usually the questions are on V.O.T.Es, standing waves, Doppler effect, or wave speed and stuff like that. Okay? You will not find pressure wave related questions too often, but you'd never know. If it comes, it's very simple, guys. Okay. Cool. Let's get going to the next one. Now let's start with some questions. If the change in temperature of the if there is some change in the temperature of the medium, then which of the following will change? Only one of them is correct. If the medium's temperature changes, then which of the following will change? Will the frequency change? Will the amplitude change? Will the wavelength change? Will the loudness change? Come on, think about it. Number of moles will not come. Krito? Nope, it will not come. I mean, I'm not sure why number of moles you said, because gamma RT by M mein, that M is molecular weight, not number of moles. Gamma is Cp by Cv ratio, T is temperature. Ankit says B. I'm not sure. Let's see. Satyendra says D. Come on, come on, come on, everyone, come on, all the minions, come on, all my warriors. Think about it. Which of the following is correct? Which of the following is correct? Very interesting answer. Come on, come on, come on. Satyendra says D. Snail says C. Think carefully, think carefully, think carefully. Guys, if temperature changes, what will change? Wave speed will change. If temperature changes, wave speed will change. If you remember, just in the previous slide, I told you velocity of sound is gamma RT by M. Gamma RT by M. I just told you about this. So you can see that temperature affects velocity. Okay. Now, what will velocity do? Think about it. Velocity is frequency into wavelength, correct? Now, will velocity change frequency or wavelength? The answer is simple. Frequency will not change because frequency depends on the source. The source will vibrate and the vibrations decide the frequency of the sound. So, frequency is decided by the source. The source did not change. The medium's temperature has changed. So, wavelength will change. So, naturally, C should be the answer. I guess a lot of you got it wrong. Lot of you got it wrong. Now, there is an important trick I will tell you. Very important trick. And this is the flowchart you should remember. Velocity, then you have frequency, and then you have wavelength, and then you have basically over here the medium. Now remember, the medium decides velocity. What does medium decide? Velocity. The source decides frequency, and velocity and frequency together decide wavelength. This is the flow chart you should follow. If you follow this flow chart, you will never mess up these questions. Because a lot of people get confused. Sir, if frequency increases, what will increase? Sir, if wave speed increases, what increase? So you should know who affects whom. If frequency increases, velocity does not change. Wavelength will change. Keep this in mind. If wave velocity changes, frequency won't change, wavelength changes. So wavelength is the last person who is dependent. So that's the answer. Has everybody understood this? Very good, Snail. Very good. You understood this. Yes, a lot of people saying, oh, yes, Rookie Foxtrot, the answer is wavelength. Okay, no problem. That's why you have come here to learn from all these zero to hero series questions. Get ready for the next one. The water waves produced by a boat which is moving in water is which form? Neither longitudinal nor transverse, both only longitudinal or only transverse. Come on, think about it. No. Satyendra, loudness does not mean frequency. Loudness means amplitude. So the amplitude also is dependent on the source. All right, and the distance. How far you are and how intense the source is decides the amplitude as well as the loudness, both of them. Okay, Jacob. All right, Fatima, welcome. Yes, poor wavelength gets decided at the last. Yes, come on, let's see. A lot of you are saying B or C. I'm not sure. Manoj says B. Liger says D. is, oh, Ankit, favorite chapter. I'll tell you why probably it would be the favorite chapter, because the questions which come from this chapter are actually very easy, guys. Yes, believe me, trust me on that. Okay, and guys, the answer is, come on, have you seen a motorboat? Have you seen a motorboat? Okay, I'm going to stand in front of the answer. I have just clicked on the answer. Guys, this is what it is. What kind of waves are there? What kind of waves are there? Both kind of waves are there. You can see that. Yes, the answer is B. Correct. Both kinds are there, both longitudinal and transverse. The water will not only move up and down, but it will also create longitudinal waves, because sound is going to travel through water as well. If sound is going to travel through water, what kind of wave is sound? Sound is a longitudinal wave, and the waves also move up and down, up and down. So there is transverse. So both kind of waves are there. All right. Yes, Vasu, 0 to hero on electrostatics is already done. It's already there in the playlist. In case you have missed any of our previous classes, guys, you can definitely go check it out in our playlist section. If you go to Enthuse channel, you can see that over here, that we have a beautiful playlist. So let's say you go to the physics playlist over here, just click on it, and you can see all the chapters of Flash series have been arranged, plus you have important tips and strategy sessions, tricks, important chapters, all these things in this playlist. And you have the Pathfinder series, which is the 12th standard series, and this is a 0 to hero quick revision. Oh my god. Okay, please stop, woman. Okay, yes. So there we go. 0 to hero, center of mass, communication, collisions, rotation, semiconductors, electrostatics. You can see that over here. Electrostatics done already. Okay, so all the things which are done are always there in the playlist. Don't worry about it. Okay, cool. Let's get going to the next question. Yes, water waves. My god, this picture reminds me of going for a vacation. Guys, how many of you did not go for any vacation last year? Come on, raise your hand. Please put it up. Just let me know in the chat box. How many of you guys did not go for any vacation? Because I don't know whether I should count. I didn't go on any vacation because I just went very close to my place in Bangalore. I hardly, yes, please, yeah. Okay, Snehal. All right, yeah, this boat is beautiful. I have this dream. I always want to go on a yacht and relax on it, and just chill out on a yacht and just probably have calm waters and probably go for fishing and just go for a swim and just come back and probably conduct a YouTube class from there as well. I mean, just chill out and have a, I don't know, coffee with Shreyas session from a nice beach location. I always want to do that. All right, a lot of you did not go on any. Okay, Kirito went to Dragon Spine. I'm guessing it's a place in anime. Corona was on vacation, not me. Good one, Yalini. Oh my god. Anytime moved in a motorboat? Yes, many times. When I went to Mauritius, when I went to even Seychelles, and when I went to Goa, yes, all the 3 times I've gone in motorboats, and I love motorboat rides. They're fun, and especially when you get that feeling that it's going to collapse, but it's not collapsing. All right, so let's get going. Too much of discussion on vacation, and probably we are going to get carried away very soon. Okay, so this is the equation of a wave on a string, and density, linear mass, mu is given 0.04. Wave equation is given, tension in the string is question. Happy Ugadi, Venu. I guess you were not there yesterday. I wished everyone happy Ugadi. Thank you. And today is Vishu. Yeah, that's what some of our cool students from Kerala also wished us happy Vishu, and the same goes for all of them. Yes, Goa is in my village. My God, Snehal is from Goa. How cool. Okay, so let's get going. Yes, it's a virtual place. I guessed it, monkey. Okay, so let's see how can we do this question. Let's start doing this. We know the wave equation, we know mu. So from this, we can do one thing. Remember, wave speed was coefficient of t, which is b, upon coefficient of x. That's how it goes. Coefficient of time. Now, what is the coefficient of time? Coefficient of time is 1 upon 0.04. Coefficient of x, what is it? 0.5. Correct? So shift it on the top. So this is going to become 0.5 divided by 0.04, but let me keep it as 5 divided by 0.4. Just leave it like that, it's okay. Now remember, there is one more formula for velocity, and that is root of T by mu. That's the standard formula, root of tension by linear mass density, kg per meter. That clearly tells me tension, that's what we will need to figure out, is the square of the velocity into mu. You square both sides and shift mu on the top. So this is going to be v square, that means 5 square, by 0.4 square, that is 4 square, into 10 to the power minus 2. That's what I'm going to get at the bottom, multiplied by mu. Mu is 0.04, that is 4 into, this one is 4 into 10 to the power minus 2. Alright, 4 into 10 to the power minus 2. Now 10 to the power minus 2 and 10 to the power minus 2 gets off 4, and one of these 4s goes off, and we have 5 square by 4, which is 25 by 4. Now what is 25 by 4? I guess it is 6.25 newtons, and that's the answer. Good morning, Pooja Patra, welcome aboard. Yes, Liger, I know you wished me yesterday, very good. Alright. Yes, thank you, Yalini, for all the wishes. Yes, happy Tamil New Year. I'm guessing you guys ate a lot yesterday because of the festivities. What all did you guys eat? Please let me know in the comment section or in the chat box. Alright, so that's the answer, guys. Answer is D. I hope you understood. Two formulas were there. Wave speed is coefficient of time upon coefficient of x. Second formula is velocity is root of tension by mu. Both the formulas are there. I have used both the formulas, and that's the only way to get it. Now, again, based on the same concept, same formula, but a different variety of question for all of you. String's mass is given, total. String's length is given to be 20 meters, not 200, 20 meters. Tension is given to be 200 Newton. What is the time taken by a wave to reach from one side to the other side? So I'm guessing if you know the wave speed, you can figure it out. How much time will it take to go for a wave to go from one side to the other side if all these quantities like tension, length, mass are given to you? Come on, guys, let's see how many of you can figure this out. Thank you, Gayatri, so much. Hi, Sahil, welcome aboard. Oh my god, Snehal, then there is going to be a flood in the chat box. Yes, for sure. Yeah, and what was your favorite from yesterday's food? Oh my god, probably we should have a discussion later on. Okay, because it will be very distractive then. Okay, come on, guys, let's focus. So, first of all, let's figure out velocity. Velocity is root of tension by mu. Now, what is tension? Tension is 200. Okay, mu. This is, please understand, this is mass per unit length. Now the mass of the string is 2.5. The length of the string is how much? 20 meters. So this will become 200 multiplied by 20 divided by 2.5. Isn't that right? Alright. So you can also write this as 2.5 is 5 by 2. So this will become 200 multiplied by 20, and 2.5 is 5 divided by 2, so that 2 goes on the top. Keep this in mind. Okay, so now once you have this, leave it aside, leave it aside. Now just think, guys, you have a string and you create a disturbance. It has to go from one side to the other. All right, how much time will it take if the length is already mentioned to you? The length is already mentioned. How much time will this disturbance take? I think that time will be distance divided by speed, and that distance is 20 meters, and that speed over there. Oh, wait, can we calculate this? I think so. I think so. Guys, this 5 and 20, this will become 4. 4 2s are 8. 8 2s are 16. So this will be root of 1600, which is going to be 40. Is it not going to be 40 meters per second? Just check this out. It's going to be 40 meters per second, and 20 by 40 is nothing but 0.5 seconds. And where is it? Yes, option B is correct. I think some of you have already answered. Very good, Krishna Mohan. Excellent. Very good. Ankit also answered. Very good. Nilohit Kashyap. Welcome. Very good. Satyendra, not 2.5. Be careful. Yes, 20 by 40, distance by speed. Very good, people, very good. You guys are smart, you guys are active. Very good. Yes, excellent. So guys, are you loving those morning classes? And if you're loving the morning classes, do not forget to hit the like button down there, because your love and support means a lot for all of us out here. Yes, please do that. And remember, the whole point of morning classes is to make sure that you get in the habit of waking up early and making your days longer. And that's the whole thing. And you will realize it very soon. And you're going to thank me for that. Next question coming up on your screen. A sound wave is passed. All right, a sound wave is passed through air column in the form of compression and rarefaction. The consecutive compressions and rarefactions, what is same? So there is compression, rarefaction, compression, rarefaction. What do you think is same amongst all of them? Is density constant? Is Boyle's law obeyed? Is bulk modulus of air oscillates? Or there is no transfer of heat? Come on, think about it. Come on, everyone, think about it. Which of the following, only one of them is true. Which of the following is true? If you remember a speed of sound, probably you will get it. Yes, come on. There is no transfer of heat. Ankit says C, bulk modulus of air oscillates. Okay, Monkey also says C. Anita says D, Gayatri says C. Well, interesting. Guys, remember, Newton gave the formula for bulk modulus, for wave speed, and when Newton, velocity of speed according to Newton was P by rho. Alright, there was no gamma, and he assumed that the process is isothermal, and when he found out the actual speed, it was very different from the calculated one. So hence, Newton's theory was discarded, and that was replaced by Laplace. Yes, and that is also called as Laplace correction. And according to him, it is gamma P by rho, and that comes because he assumed the process to be adiabatic in nature. Adiabatic means no transfer of heat. So none of the other options are correct. Yes, Laplace is adiabatic. So guys, the process is so fast. Compression, rarefaction. Before the molecule thinks, oh my god, what happened? It will be like, oh my god, I don't have time to exchange heat. So the molecule is going to be in a fix. It won't have time. Before it thinks, the next compression has come. Before it thinks, the next rarefaction has come. So it won't have time to actually exchange the heat. And that's why the answer is D. Yes, that's correct. Okay, yes. Correcto. Interesting. Let's get going. Yes. Interference of sound. Now remember, whenever you have two waves and their amplitudes are, if you have two waves like this and like this, this is amplitude A1, this is amplitude A2, and there is some path difference, delta x. This path difference creates, alright, a phase difference given by 2 pi by lambda into delta x. This is your phase difference. This is your phase difference, and this one over here is your path difference. And when these two merge and then they produce a resultant wave of A, remember this resultant A can be found by vector addition. How? You take the resultant amplitude A can be found by vector addition. Take the two waves amplitudes A1, A2, but the difference between the two vectors should be angle wise, the phase difference. So take the phase difference as the angle between the two vectors. The resultant which you get will be the amplitude of the resultant wave. That's what has been written down over here. Yep, keep this in mind. So whenever two waves having some difference in the path delta x produce a phase difference given by this formula, the resultant wave's amplitude is this, and if the two waves are together, it is constructive interference. The resultant's amplitude will be A1 plus A2, they'll be on top of each other, and if they are separated such that the phase difference is pi radians or 3 pi radians or 5 pi radians, that's what has been written over here. Any odd number, like so, any odd number of pi radians, then it will be destructive interference. The crest will merge on the trough and the resultant amplitude will be A1 minus A2. I hope this is clear. Good morning, Tanu. Welcome aboard. You're a little bit late, but it's okay. You can continue watching the session from here. We are going to do a lot of questions. All right. Next thing, beat frequency. You should know this. Beat frequency. Hi, Viknesh. Welcome aboard. Beat frequency. Whenever you have two sounds, look at this, yellow and green sound, but slightly different frequency together, then you will get a resultant sound who varies in time. And it varies something like this. The amplitude is large, then low, large, then low, large and low. So the amplitude varies because there is a difference in the frequencies. I have shown this to you in flash series as well. And this waxing and waning, increasing and decreasing intensity of sound is something which you get when you strike two bells of a temple at the same time. Have you done that? I am pretty sure you will be able to recollect how the sound of the bells of a temple, those big bells, you strike both of them together, it keeps on increasing. Dang. That sound that you get, it increases, decreases, decreases, increases. That's what happens. Hi Shrinu, welcome aboard. Hi, good morning Jagdish. Thank you for all the love from Bangalore. Yeah, that's where I am. Yes. So guys, that is beats, and the beat frequency is given by omega 1 minus omega 2. Keep this in mind. F1 minus F2, frequency of 1 minus frequency of 2. That's beat frequency, okay? So let's see how many of you can do this. The first question coming up on your screen now. Very good, a lot of you have heard it. Very good. So that says that you guys visit temples, so that's very good. Okay, two sound waves with wavelengths 5 meters and 5.5 meters. Wavelengths are given and the wave speed is going to be 330. How many beats per second do you expect? Oh my God, Snail, been a long time. Okay. Chalo, no problem. So there we have how many beats per second. Satyendra, ambulance. Well, ambulance is slightly different. Ambulance produces different frequencies. High frequency, low frequency. High frequency, low frequency. That's not what beats is. Beats is amplitude changes. That's the difference. Okay. Okay, cool. Let's see. Interesting. Come on, let's see. What do we do? I think the first thing you need to do is figure out frequency. Remember, beat frequency is higher frequency minus lower frequency, F1 minus F2. And what is frequency? Speed divided by wavelength. Speed divided by wavelength, correct? So basically C is common and we have 1 by lambda 1 minus 1 by lambda 2. Because wave speed is frequency into wavelength. So C is how much? 330. And what is the wavelength number 1? That's 5. And the other wavelength, it's 5.5. Okay, let's see what do we get. So we have 330 and 5.5. So here we have 5.5, taking the LCM, minus 5 divided by 5 multiplied by 5.5. That's what we are going to get. 5.5 minus 5, 0.5. So it is going to be 330 multiplied by 0.5 divided by 5 into 5.5. So 5 into 5.5. Okay, so you can remove the decimals. So it is going to be 330 multiplied by 5 divided by 5 into 55. So I would remove the decimal. Now it becomes simple because this 5 and this 5 goes and 55 goes with 330 6 times. So there we have the answer as 6. Very good, Rudresh. Very good, Tanu. Very good, Kajal. Looks like you guys got it. Yes, yes. Aviram, I'm guessing the answer is not 63, it is 6. Yes, Satyendra, very good, excelente, excelente. Let's move ahead. Beautiful. So if you know wavelength, you can also find the beat frequency. Let's see if you can solve the next question. Beautiful question based on reflection. Imagine, okay, imagine guys, you have a wave, okay, which goes like this and basically it gets reflected from a denser medium. It goes like this and it reflects back and comes. So the question is, if the incident wave's equation is this, 0.6 sine 2 pi t minus x by 2, that's the incident wave's equation, then because of the reflection from a denser or from a fixed end, what will be the reflected wave's equation going to be if the reflected wave's amplitude is 2/3 of the incident's amplitude? Very good, Yalini, understood. Very good, monkey. Excellent. Come on, let's see if you can do this beautiful question. Small trick And if you know that, that's it. It's very easy. Trust me, you cannot lose marks over here. If this question comes, you're going to remember me. Thank you, Jagdish. That's why I'm waking up in the morning. Yes, for all of you. I mean, even if the series was not there, I would still wake up in the morning, but still, yes. So I want you to get into a habit, and plus I want to make sure that we revise all the important chapters before your April attempt of examination. Okay, a lot of you are saying C. Why doesn't JEE allow calculator? I mean, they want to test our concepts, yes. But Snehal, that's the thing. You need to be also be very good at calculations, because let me tell you, in real life, when you're talking to someone, or even when you're talking to a shopkeeper, or whenever you're bargaining on something, it could be anything. Maybe you are buying something and you want to bargain, maybe you're investing some money in stocks, or you want to talk about percentages, you are negotiating something with a bank. You need to be really quick with calculations. It's been a proven fact, and I'm not kidding. And in fact, I have seen this personally. People who are very fast, very quick at calculations also progress really fast in life eventually. That's what I have seen. I'm not sure whether you will also experience the same thing as you go ahead in life, but that's what I have seen. Nobody will sit at the calculator. Acha, shopkeeper told me, acha, he has 200 rupees, he has 5 rupee change, and I have 20 rupees, and then how many coins do I have? I'll sit with the calculator, open my phone, and then press some buttons, and then get something. The shopkeeper is going to look at me with so much of, I don't know, disgust, or I don't know, he's going to be really mad at me. So don't do that. Yeah. So guys, I'll tell you what. First of all, this wave, which is incident, will be reflected back. It will be reflected back, and instead of a crest, you'll get a trough. So first of all, you are going to get this thing. Yes, inverted. The wave will be inverted, number one, and the amplitude which is there. So 0.6 multiplied by 2/3. What is 2/3 of 0.6, guys? Isn't 8.4? The amplitude, this is the new amplitude. So that's it. So where is 0.4? 0.4. So A option is gone. I hope you see that A option is gone. Correct? Okay. No problems, Neil. It's okay. Probably you will realize it later on. It's okay. Happens. Okay. So these three options. Now be careful. There was a minus sign over there. Minus sign. Minus sign means the wave was going towards your right side. Minus sign. So when it reflects back, there should be a plus sign. Okay. Now plus sign is there only in these two options. You can see that. This one has a minus sign. So this option also gets eliminated because the wave is coming in the opposite way. And the last thing, because the crest becomes trough, so that plus 0.4 should become minus 0.4, which is there over here. This minus 0.4. Hence, this is the correct answer. Yes, that's the correct option. Understood, guys? Beautiful concept, lovely question, and that's how you need to solve it. Okay, let's get moving to the next one. Get ready. Okay, just 1 second. Let me also drink some water meanwhile, and let me show you the next theory slide, which is going to come up on your screen. Okay, and before we go ahead, yes, Andrew, it's a nice question. This is how our wave platform looks like. Have a look at it. See how it looks like for next 10-20 seconds before we move ahead and I drink some water. Yalini, that minus 0.4 came because the crest became a trough. So that positive equation will become negative. It will flip like this. So that's why that minus, because of the phase inversion. Okay? Okay. Yes. Yes, I think Kirito also said it. Okay. By the way, this is our wave platform. This is how it looks like. And guys, you can also ask doubts on our wave platform. So all the 11th to 12th moving students, if you have not yet joined our pro subscription, or if you are doubtful about what is there in the pro subscription, this is how our platform looks like, and this is our doubt app where you can actually ask a lot of doubts by sending screenshots out there. Oops. Okay. Yeah, let's get moving. Oh my god, did I just realize something? Oh, I can go back like this. Oh, I didn't know that. I didn't know that. All this while I used to use my remote to go back. Oh, this is interesting, guys. I just discovered accidentally. Yes, please go back. Oh, I can go back. Nice. Woohoo! I discovered. Maybe not India, I'm not like Columbus, but I discovered that I can swipe and go back and forward. Oops, yes, I can do that. Interesting. Yep. So this is how discoveries happen accidentally. So you need to keep trying, guys, in life beautifully. Alright, so we have standing waves. Standing wave equation 2a sine or cos kx, again sine or cos omega t. So standing waves, when two waves move in opposite direction, then they produce standing waves. The standing wave equation is 2a sine or cos, doesn't matter, kx, again sine or cos omega t. Those points which do not move are called nodes. Those points which move a lot are called antinodes. Yes, Neil, I am not kidding. This was seriously, I actually discovered it right now in front of you. I used to Google this. I'm like, how do I go back? I used to always have to use this remote. I mean, I'm not quite a fan of remotes, you know. So I don't like using remotes. I mean, like going forward, yeah, okay, and going backward. I don't like holding this. Already I'm holding this pen, which is quite huge. I don't want to hold one more thing, and then I'm just helpless. I don't have more hands to hold more things, and then I have to drink water. Then I have to, you know, just probably use my hands for something. Yep. And sometimes I also need to use my hand for drinking coffee or eating chocolate sticks, or probably eating some chocolate or some nice Oreo biscuits, you know. So I'm not a god with 5-6 hands. I would love to have that. I mean, but right now I don't have that. Okay, so that's how it goes. Okay, so a lot of theory slides are there for all of you, so that you can read through it, browse through it later on. Let's go to the questions and let's see how to actually apply these things in the questions, so you will understand it. So all the slides, I have kept all the theory, so don't worry about it. All right, so let's get ready for the questions. Yep. Is the batch started for 11th, Rishi? Super excited for tomorrow's class 11th. Well, Rishi, I'm going to start class 11th, topics very soon next week. For now, we are doing 11th to 12th moving, for all the 11th to 12th moving students, we have started the Pathfinder series, the long-term course. For the 2021 aspirants, we have started already. We are continuing the 0 to hero and also killer 5 questions of JEE Advanced. That's what we have done. And yep, the 11th standard students, don't worry, we are coming up with a bridge course as well. Yes, bridge course. Yes, I changed the slide. Yep. Okay. So cool, guys. A standing wave having 3 nodes, 2 antinodes is formed between 2 atoms having a distance of 1.21 Armstrong between them. Then the wavelength of the standing wave is, come on. Okay. Come on. Yes, gone mad. Yes, Yalini, gone mad. I forgot the name. Yes. It was not clicking me that time. Yes, gone mad. Gone mad sticks. I love it. Guys, when I have a lot of followers, trust me, I'm going to advertise for Gone Mad and Oreo, and I'm going to ask for a lot of money from them. Yes, trust me on that. Okay. Kidding, guys. Okay. Chalo, let's do this. Okay, so first of all, we have 3 nodes and 2 antinodes between 2 atoms. 3 nodes and 2 antinodes. Achha, that means like this. So 1, 2, 3 nodes and 2 antinodes. So that's how it looks like. So guys, isn't this one wavelength? Can you see that? This is one wavelength, and this is also the distance between the 2 atoms. There is an atom here and there is an atom here. So that's the distance between them. And it's also one wavelength. So the distance between the 2 atoms is 1.21 Armstrong. So hence the wavelength is also going to be 1.21 Armstrong. That's it. Yep. That's it. Yep. Okay. Yeah, that's how it goes. Yeah. So that's the answer. Very easy. I didn't write even one equation. That's the best part about this. So that's how you do this. 1.21 Armstrong. Done. Let's go to the next question. Let's see how many of you are going to get confused. Very confusing question, but very easy, direct question. with an open end organ pipe of length L, the fundamental tone has a frequency. Open end organ pipe, what's the fundamental frequency and what are the higher frequencies? Come on, think about it. Rudresh already says A. Yes, Andrew, very simple logic, correct. And that's how you need to look at standing waves. If you look at the formulas, then it is very confusing, and I usually don't love so many formulas. I love keeping it simple because we are learning physics, not too much of maths, unless and until it is absolutely necessary to use derivatives, integration, trigonometry, algebra. Unless and until that, we are going to definitely continue looking at it through physics perspective. Thank you, Suyog. I hope you had a lovely Gudi Padwa yesterday, and I know you are not there yesterday, but yes. Okay, glad you're here, and please watch the replay. Yeah. I have already gone mad, so for me some commission. Oh yes, Yalini, for sure. Commission, definitely for you, Yalini. Okay. Rappers. Lot of rappers for you, Yalini. Okay. Okay. I keep the convert, you keep the rappers. Is it a deal? No deal? Yeah. Okay. So guys, the answer is simple. It's very simple. When it's an open-ended organ pipe. Open organ pipe means what? Keep this in mind. Open organ pipe. Guys, open-ended organ pipe means, both sides are actually open. Yes, both sides are actually open. This is the meaning of open pipe. And when one side is closed, that is called as a closed organ pipe. Now this one, where both sides are closed, that is not there in JEE syllabus. It's not there. I mean, it doesn't make sense. How can you have two sides closed? How are you going to produce the wave? That's the problem. So this is not there. So remember, whenever I say open, it means both sides open, and whenever I say closed, it means one side is closed. That's the meaning of that. Okay. Cool. Yes, a lot of people get confused, and hence the formula that you will use. What's the formula for this pipe? The frequency is NV by 2L. So all frequencies are present, odd harmonics as well as even harmonics. So even is also present and odd is also present. Only in case of this one you have odd harmonics, odd number is there. Okay, so keep that in mind. Very beautiful question. Let's get moving to the next one. A resonating air column of length 20 centimeters and it resonates with a tuning fork of this much frequency, 450 hertz. Forget the end correction. What is the velocity of sound in air? Resonance tube experiment. No problem. Happens. Okay, looks like Yalini did not take the deal. No problem. Okay. Come on, Praveen. Yes, I'm not sure why you're saying what. We are not asking the unit of power, but I'm guessing you're surprised. Okay, so resonance column experiment. Come on, guys, let's do this. So, what happens over here is that you have that tube like this, and it is dipped in water or some liquid, and this is given. This length is 20 centimeters. That's what is given, and you have a tuning fork over here of 450 hertz. That's what is given. So the formula that you use for these kind of questions, the formula that you use is frequency is NV by 4L, because you will get this kind of a standing wave over here. You will have a node, and here you will have anti-node. Keep this in mind. You will have anti-node over here, and you will have node over here. That's what you're going to get. Here, the value of N is going to be 1. The frequency is going to be 450. N is 1. V, I don't know. 4 into length. Length is 0.2. So V is 450 multiplied by 4 multiplied by 0.2, which is going to be, how much is it going to be? Is it going to be 360, guys? Just check this out. 360 meters per second. Yes, that's the answer. Oh my God, Sakti, long time. Where were you these days? Not seeing you these days. I hope you're all fine. Okay. Understood. Yes. Guys, I'll tell you, Satyendra, there is no separate formula for resonance. It's the same formula for organ pipes. Just keep that in mind, that this is a closed-ended organ pipe. One end is closed, one end is open. So that's how it works. And if there is end correction also, what happens is, in case of end correction, this L will be replaced by, alright, L plus E. So that's the only change when you have end correction. So keep that in mind. Rest everything else is similar, all right? So you don't have to worry about it. All right. Thank you, Tanu. Glad you're loving the session. Welcome, Ati Gopi. Okay. Now I'm watching your recorded rotation lecture. Bharni, please concentrate on the live class. Then you can watch the recorded class. Then you'll have to watch this also recorded. So don't do that. Okay, beautiful question coming up on your screen. Amplitude of a wave is given by this. Resonance will occur when only one of the option is correct. Think about it. Oh my God, school pre-board examination. Okay, Shakti, please watch the recorded classes at least later on. Chalo, let's do this. It's resonating, then what will happen? Resonating. Come on, come on, come on. It's resonating, then which of the following option will be correct? Only one of them is correct. Let's see how many of you can do that. What is the meaning of resonance? The meaning of resonance is that amplitude is large, very large. It's very large. If you want to make this amplitude very large, that means this denominator should be very small, in fact tending towards 0 if this amplitude tends towards infinity. Very large amplitude, very infinitely large, so denominator should be infinitely small. Now which of the following situations do you think this denominator will become small? B is minus c by 2? No, I mean minus c by 2, how will it become small? No. B is minus a by 2? No. B is 0, A is C? Well, B is 0 and A is equal to C. So you are going to get this as 0. Oh, the denominator will become very small, close to 0. Yes, the correct answer is actually option C. Yes, that's the answer. Looks like many of you got it. Excellent. So the whole idea was to make the amplitude large by making the denominator small, and then check just check manually which of the options makes the denominator very small. As simple as that. Let's get moving to the next one. Okay, now let's do a question on Doppler effect, guys. Yep, get ready. Doppler effect, the standard formula. So first of all, what is Doppler effect? Whenever a source or a detector moves relative to each other, then you detect a change in the frequency, which you call it as the apparent frequency, and that depends on both the speed of sound, the speed of the source, the speed of the detector, and also the original frequency. And the formula is given by, okay, if it looks confusing for all of you, this one, a lot of V's out here, it's okay, ignore this. So use this. F apparent is basically F actual into, all right, speed of sound plus or minus speed of detector, C plus or speed of source. Remember, D is on the top, S is over here. This is source, all right, and this is the detector. Keep this in mind. Now the plus and minus sign comes depending on whether the source is approaching the detector or whether the detector is moving away or close. So it all matters. Always remember one thing, guys, the signs are decided by keeping this in mind. I have told you this trick. The trick is, look at this number. This is a fraction. Try to increase or decrease this fraction by changing the signs. Answer this question. If the source moves towards the detector, the frequency should increase or should it decrease? Welcome, Amol. Nice to see you out here. This is an English channel for all the English medium students who want to prepare for JEE, NEET, and any such competitive exams, be it V.O.T.E, EEE or CETs or stuff like that. So we are right now conducting the 0 to Hero One Shot series of all the important chapters of 11th and 12th, and today is waves on a string and sound waves. Okay, if it is a non-inertial sound, no, even if it is a non-inertial frame, still you can apply it. Okay, don't worry about it, Sakti. Yep, any frame you can apply it. Don't worry about it. It will increase, correct. Now if it increases, that means this fraction should also increase. So you should try and increase the fraction. So if detector is moving, assume that the detector is moving, then obviously put a plus sign, because that's the only way you can move the you can change the fraction. And if the source is moving, then you have to reduce the denominator, so put a minus sign. So guys, always play with the fraction, and if you know that the fraction should increase because the frequency should increase, then increase the numerator, decrease the denominator. If the frequency should decrease, then the fraction should also decrease. That means numerator should decrease and denominator should increase. So that's how it works. Hello Vaishnavi, yes, what happened? Why have you joined after a long time? What happened? Everything fine? Or you also had some pre-board examinations? And there we go with the next question coming up on your screen. Yes, come on, come on, come on, come on, everyone. There is a train which goes, all right, with a constant speed, whistling with a constant frequency. Now, the train goes past a stationary observer on the station. So the question is, how will the frequency graph look like? Okay, so there we have, yep, there is, yep. Okay, you have a pandu over here and there is a train like this. So guys, think about it. Oops, this is an electric train. I'm not sure why I drew the smoke. But anyways, you get the idea, right? Yeah. So maybe the train is on fire. Okay. Fire in the hole. All right. Come on, guys. How will the frequency heard by this guy look like? The train is whistling continuously. So there is sound coming out from the train and the pandu at the station hears it. Very good, Ankit, making all the notes. Excelente. Option D or B. Monkey says B. Praveen says D. Interestingo. I don't know. Let's see. Guys, think carefully. Think carefully. My God, Liger. Aman, yes, I have started taking classes in the morning because I want you to get into the habit of waking up in the morning, number one. Number two, all the classes in the evening are crowded. And number three, I think relatively you are free in the morning. So plus you are fresh and a lot of things. I'm pretty sure you guys are enjoying this class in the morning as well. And if you're enjoying the class, please let me know by showing your support by hitting the like button. And if you're new to this channel, do not forget to hit the subscribe button. Yes, in case you have forgotten that. Hit the subscribe button and hit the like button, guys. It means a lot for me. Okay, so guys, the thing is, when the train approaches, all right, when the train approaches, all right, the frequency will be more, will be higher. And as soon as the train passes by, yes, it moves away, the frequency will be less. Now, it's not A, it's not B, it's not D, it should be C, guys, because when he's approaching with a constant speed, the frequency will be higher by a constant magnitude. He's approaching with a constant speed, constant frequency, so it will be higher. And as soon as it moves away, that plus will change to minus or that minus will change to plus, and that's it. So there is only a change of sign. So sign will invert because the frequency will suddenly drop, and that's why you're going to have option C over there. Yes, option C is correct. I hope you guys got it. Very good, Snail, you'll love it. Okay, very good. Yes, yes. Okay, let's get going to the next question coming up on your screen. Okay, there we go. A driver in the car approaches a wall. I don't know what the hell is he doing, but yeah, he's doing something. So there is a wall. Oops, where is it? Yep. Okay, so this is our wall and this is our car. Okay, yep, beautiful looking car. There you have. Yep, and he's approaching the wall. He's going like this. Okay, and he is also yeah, he's approaching the wall and notices the frequency of his car's horn. So the sound which is generated, all right, will get reflected as well. So the frequency which he hears changes from 440 to 480. So the question is, what is the speed of the car? I think you can do that. Okay, Snehal, I hope now you will not get confused with the signs. You don't even need the knowledge of signs for the previous question. You just need to think logically. If you approach relatively, it will always increase. If you move away relatively, it will always decrease. That's all you need to keep in mind. Okay. Yeah, maybe the parking area car. Yeah, I mean, Tesla won't allow you to bang yourself against the wall. I mean, Tesla will stop it. Yeah, unless the autopilot is off. Okay, so that's how it's good. Okay. Very good, Amrita Raj. I am so happy. This means a lot. I mean, if I'm able to make even a small change, 1% change in all of you, I will be the happiest person out here. You just made my morning. Thank you so much. Oh my God. Okay. Well, I have gone to Bangkok And I'm not sure what's the relationship between Bangkok and this question. Ankit. Okay, option A. Okay, let's see how to solve this. Guys, there is a trick to solve these questions, and the trick is assume that the wall is a mirror. What should you do? Assume the wall is a mirror and think there is a judwa, there is a duplicate, there is a identical car like this. Oops, yeah, like this, and it is coming like that. And think as if the wall is no longer present and this car is generating sound which is then heard by this person. That's what you need to do. Yes, and then this becomes the source, and then this becomes the detector. Yes, this becomes the detector. So forget that there is a wall, just assume the reflection and then solve the problem. This is the trick. So apparent frequency 440 to 480, so it changes to 480, is equal to 440 multiplied by speed of sound, yes, 330. Oops, my bad. So you have 330 on the top, 330 below, and remember the source is moving towards, and source speed I don't know, but understand when the source moves towards, the frequency should increase, so denominator should decrease. So that's why decrease the denominator to increase this fraction. And the detector is also moving towards. So guys, understand, he will also contribute in the increase of the frequency, so plus V, because numerator has to increase. Remember, numerator is for detector and denominator is for source. Keep this in mind. Okay, now just solve this equation. You're going to get the answer as A, 14.3. Yep. Thank you, Snehal. Oh my god, it means a lot. It means a lot. Yes. So be careful with the signs. The whole idea is play with the fraction. See, the detector moves towards the source. Where is the detector's contribution? It's in the numerator. So it should increase the numerator. That's why plus. The source is moving towards the detector. So again, it should increase the frequency. And where is the source speed? It is below. So decrease the denominator. That's all it is. And that's why you get the answer as 14.3. Okay. Yes. A driver in the car. Yes. This kind of questions use the trick. The trick is mirror the cars. Think of the car as an object and mirror the car behind the wall as if it's an image which is formed, and that image is the source. That's what the trick is. So guys, let me tell you about some of the toppers which have been produced, and let me tell you about this year's results. In fact, so just to give you a basic idea, above 99 percentile in JEE Mains first attempt, 45 students were there. 45 students above 99 percentile from Vedantu in JEE Mains February attempt. 96 to 98.99, 123 students. 90 to 95.99, 184 students just in the first attempt. Second attempt, these numbers have gone up more. I'll show you the results very soon in few lectures. Almost 1 in 2 students have qualified for JEE Advanced through these results. Almost there are 11 students in physics, 6 students in maths, and 2 students in chemistry who have got 100 percentile. That's very interesting. And yeah, there are almost like 1,528 students who have scored more than 90 percentile through Vedantu. Yep, this is what the power of online education is. Lot of people last year or even before that used to think, oh, how can I learn from YouTube? Oh, how can I learn sitting in front of a laptop? How can I learn, when I cannot see the teacher in front of me? But you guys have understood the benefit of not having to travel and having the option of watching the replays, having the option of getting the notes online, getting those PDFs, watching those lectures again and again for better conceptual clarity, having those quizzes, having those discussions, having that options, variety, flexibility, where, in case you miss a lecture or if 2 lectures clash, you have that option to, watch the recording and all this stuff. And that's what online education has done. So guys, please check out the crash course if you want to be one of those numbers who get more than 99 percentile, more than 90 percentile in April and May attempt. Believe me, it's going to make a change. So go check out the crash course link which is there in the description box. The first crash course has already started on 5th April. You can watch the replays in case you want to finish the crash course before April attempt. But if you are preparing for the May attempt, then you also have this option which starts on 3rd May to 20th May. So select any one of them because there's a lot of discount that is happening on this. And once you enroll into the crash course, you're going to see your courses out here. You can watch all those lectures even if you have missed them, get the notes, download the PDF and all of that. And all of this at a very affordable price, almost the price of a meal per day. That's what I would say. And the price is hardly 6,000 rupees. No, it's not 10,000, it's 6,000 rupees when you use the discount coupon SHCC. So when you use this discount coupon, if any problem happens during enrolling, you can also contact me from my Instagram handle or leave a comment. Definitely, I'll be able to help you out when you use this coupon code. So guys, do not forget the link is there in the description box. And if you feel there's a friend who will be probably needing this kind of a crash course or a relative or a cousin, please pass on the details to them as well. And yes, you will be getting the PDF of today's session on our Telegram channel, and which the link is there again in the description box. So if you loved this session, if you enjoyed this class, do not forget to hit the subscribe button if you are new, and also show your love and support by smashing that like button out there. Thank you so much guys for being here. Yes, Praveen, I'm always going to be there for all of you, even till the last exam and even after the last exam for counseling. Don't worry. Yes, bye-bye. Take care. See you tonight. Thank you, Abhimanyu. Happy wish you to you too. Bye-bye. Take care. See you tonight in the Pathfinder series. And we are going to discuss everything about dipoles tonight at 9 o'clock. See you guys, and bring in your friends as well on the Enthuse channel, which is an English medium channel for all the students preparing for all the competitive exams from 11th to 12th grade. Bye-bye. Take care. Signing off. This was Shreyas here.